What's up, YouTube? In today's video, I'm going to introduce to you the first of a new series called Design Nuggets, as you might have already seen from the title. And the idea is that there are a lot of aspects about design that they're simple, but they're difficult to explain, especially in this format, like in a video where there's no way for you to ask me questions and I can immediately clarify a certain misunderstanding or whatever, that might happen during the course. But these are nuggets, as in they're small chunks, small valuable chunks of things that I think are important. And I also want to kind of go through or show you the process of design, meaning start from somewhere and end up somewhere else kind of thing. So without further ado, I'm just going to get right into it. So let's get started. So what you're seeing here on the screen is the requirement. And I'll explain the requirement and then I'll tell you what we are going to be focusing on in today's video. The requirement is essentially we have multiple sources of information or data. And then this system here, this piece over here, needs to parse the different pieces, the different pieces of information coming from the different sources. Each one has a completely different model. So it's not like they're all trying to extract the same information from these different sources. So the models are different, meaning the DTOs or the classes that these things get parsed into are different, and the sources are different. And there can be any number of these, in the future, if you will. But for now, we're just going to focus on these three potential sources. And we're focusing on building out this piece here, where essentially we're trying to parse out the different logs, produce the models that pertain to each of these different sources of data. And then we're not going to do that, but I'll just mention briefly in the code that we then need to persist that information to some sort of a persistent store. But for now, we're just focusing on this piece here, right? So what I want you to do is think about this at any point in time, stop before you kind of get to the answer. As I want you to think for yourself and say, okay, well, yeah, how would I do this, right? But what I'm going to do in the video is to go through a process. And this is a very valuable process. I think all of us should do that. I mean, I've been doing this for many years. And sometimes some people say, well, I've done this so many times. I've got all this experience. So yeah, to hell with the experience. You still want to go through the process. The process brings about many, many valuable things that are not, they kind of go missing or they're hidden until you go through the process. And I'm not talking about this process in a mental way. Now, certain problems might warrant just a mental exercise. Certainly, if you're new to design or you're not comfortable with doing design, I suggest go through this process repeatedly for decades. You want to go through this process because there's a lot of value to this process. So we're going to go through this process. The process is establish a baseline. Whatever it is you're doing, don't start imagining the design in your head and end up in some place out of space that has no connection to what you were trying to do here, right? So when you see a requirement like this, certainly let your imagination go wild. But when it comes down to actual coding, and you need to be coding, it's not an imagination. This is not a thinking process. This is an actual work that you got to do. Write or code the baseline, the simplest form possible, the simplest functional form. That's the baseline. So let's say you're imagining, I probably have to do this multi-threaded, blah, blah, it doesn't matter. Keep the simple baseline. See how fast that baseline performs before you say, I'm going to make this multi-threaded. And I'm going to come up with a producer-consumer pattern and, whatever else. Doesn't matter. That baseline is important. All right. So I'm going to go through the baseline. Maybe you've imagined the same baseline. Either way, I hope that once I show you the baseline, you're able to sort of fit your brain into that baseline and say, okay, yeah, that's a decent baseline. And we'll go from there, right? But before you see the baseline, pause the video and imagine your own baseline. How would you do this? Right? Maybe write the code if you're so willing, right? Write the code. Experience doesn't come by listening to me or anybody else talk. Experience doesn't come by reading books. Experience doesn't come by attending conferences. Experience requires you to do and experiment and do and experiment and repeat this process over and over and over again. That's when it really kind of gives you the value of experience. Okay, so let's get started here with the actual implementation. So I'm going to start with the simple classes or the simple ideas in the system. that are sort of consistent across the different implementations, because that's nothing going to change. So if you look at here, we got a log source, and this log source is essentially telling us what the source of the data is. In our case, we have a MS SQL log source. We got the NCSA. NCSA is the body that standardizes, or W3C that has standardized the logging format for web servers, whether it's IIS or Apache or whatever the web server is. If they're trying to be conformant with the W3C standard spec, if they claim that they don't have to be, but if they claim to be, then NCSA is the standard log format for all web servers. So I just call it NCSA, even though in the actual, just call it web server logs. That's whatever the web server is. And Splunk. If you haven't used Splunk, think of it as a warehouse that houses or persists all of your logs from your applications, right? So Splunk is just another source of data. You can decide how you want to log the data in the system. It's just going to house it, right? This is schema-less in that sense. There's no schema. You decide the schema. So of course, for this exercise, I've decided a certain schema. So it's not like that's a Splunk specific thing. It's just my own schema for the information I log into my log files, and that's the way this is going to be parsed. All right, so there are 3 at this point, log sources. Each of them are named specifically, so you know which one is which. And then the model that this gets parsed to. So we have the MS SQL log info class here. And this descends from a base class. This is not required for this to descend from a base class, but this was a progression. So in the baseline, you don't need this base class. You don't. In your baseline implementation, there was no need for these models to descend from a base class. Okay, so just keep that in mind. I'm actually not a big fan of having models, DTOs, have hierarchies. It's just not, there's no value to that. I just don't see the point. You know, if they share 2 properties, it doesn't matter. They share 10 properties, I don't care. DTOs are DTOs. They just stand independently of each other. There's no purpose for them to inherit. And maybe, you know, the reason I use inheritance is not for extension. I never use inheritance for the sake of extension, which is what you're doing if you're doing this with models, right? You're just saying here's 2 properties in the base class and the descendants have 5 properties or 10 properties. The 2 are common. That's extension. I don't use inheritance for extension. It's your choice. But here in the later versions or iterations of the implementations, that comes in handy. Each of these DTOs or models have different properties, as you can see, and it's irrelevant what the properties are. So I'm not trying to show you to confuse this. It's just a model. So MS SQL has a certain shape, if you will, and certain things you might see are common. NCSA log info has got the same date time, and it's got a bunch of other things to do with HTTP servers, such as HTTP method, URI stem, status code, the so-called IIS log files or web server log files. Then my Splunk is specifically to do with exceptions. And so I call this the Splunk exception log info. And so my exceptions have certain information and that will probably be logged into Splunk. And so I need to parse that out and produce a model, right? So the idea, as I said, is you've got different sources of data input. You get that and you ingest that into your system. Your system needs to be able to parse each one of those, and they get parsed into completely different models. And then those models need to be persisted into some form of a database, data store, right? We're not talking about the persistence part, even though I might mention it. We're not going to be looking at that part at this point. So what is your baseline implementation? Given that the models I showed you just now and the enum I showed you just now, and that's going to be consistent across the different implementations. The models are not going to change because the implementation and the enum is, well, just keeping a kind of track of all the different sources we have. Have you got your implementation just conceptually in your head? Okay, let's look at the baseline implementation. So I've got this, my solution here. I'll actually put the source code in my GitHub repo, and in the description below, I'll put the link to that. But just to explain the structure of the solution. So I've got like things like the enums and exceptions, if you will, and the models. These are common, right? So they're kind of outside. Then the implementations have their own folder. So that's the baseline implementation. Then I've got intermediate implementation. Sorry, this was the implementation 1, implementation 2, and a final implementation. So essentially I've got 4 different implementations going from baseline to final. And the final, of course, in my head, that's the final. You could go even further if you wanted, but please don't. All right, so just so you understand the structure. right? So when you see this project in my repo, you don't get confused as to what I'm doing or where things have gone. Okay, so I'm going to close out all of these. I don't need you to now see the models and the enum. Let's look at the baseline. So this is the baseline. So this is for all of the code here that I show you, there's going to be some client code that calls it, right? So the code you're seeing here in all of these implementations is not showing you the code that calls or uses these classes or this class, right? So that's the part you will just keep in mind. I'm not going to show you sort of the call site. I'm showing you the actual implementation for the work that we're focusing on. So there's some class. I've intentionally just called it baseline Parse Logic just so that's clear, because that's not a good class name, but for the sake of this demonstration here, to keep things straight, the method is called parse. It takes the content. Now this content could be a single record. It could be a bunch of records. It could be the entire file that you have to decide or design upfront, right? Those are some of the decisions you have to make right up front. Like, how am I going to ingest that data from a SQL Server? How am I going to ingest it from Splunk? How am I going to ingest this data from the web servers? So let's assume for now that we're not concerned at this point with how the data is coming to us, but let's assume that it's potentially more than one record, whether it's the entire file or a portion of the file or however it may be. It's a small chunk, right? So we're just focusing on the fact that this data might be not just one record, but it could be multiple records, but it's complete record. It's not like partial information. So I'm just giving it a string and it's a log content. The first thing you want to do is by looking at the log content, we want to be able to determine the source. So of course, every source has got its own kind of format. So there's something that has to go determining what is this format? Is this the IIS logs or NCSA logs? Is this SQL Server logs? Is this Splunk exception logs? What the heck is this, right? And it comes back with an enum. So this is an enum, the log source enum. And once we have the enum, we can use, just intentionally use the switch case here. It's the simplest way to understand things. When do you decide whether you should use a switch case or a if then? Think about that. I'm not going to tell you right now. You tell me in the comments, when would you use a switch case and when would you use an if then else? Right? All right, so based is if it's a SQL Server thing, then we'll call a method that says parse MS SQL logs, giving the log content. It comes back to us with this log info. And I'm assuming for the sake of simplicity, there's a singular record here. So, but it could be a collection, but of course, I'm just making this a simple implementation. So there's a single record. And once you have that single model that comes back, you can persist it using another method. So the parse methods are different for each of these different sources. This is parse SQL logs. This is parse NCSA logs. This is parse Splunk logs. And then the persistence is also different because they each have their own different model. Now you could make this more generic and all that. That's not really the point of this at this point. This is the baseline. Remember, the baseline has to be the simplest form possible. It's like you go down, to the bare bones, to the first principles. You're not employing all kinds of magic. You're not employing polymorphism. You're certainly not employing generics and that sort of thing. It's the simplest form possible, right? Start with that. All right. Once you have this implementation, now I'm guessing this implementation of all these methods are here, right? And I'm not implemented it. So it's not like I'm showing you spending time on the parsing logic itself, but they're all here. So the DetermineLog log source is here. Whatever logic you use, you then return a enum. And then the parse logic for each of the different sources. And then there's the persistence methods for each of the sources, right? It's all in this one class. It's all implemented here. Simple implementation. Is this simple? Do you get it? Do you understand this? Cool. If you understand this, that's it. I'm done, right? It's working. I'm good. There's no need to go further. So when do you decide then? Oh yeah, right. You use solid. We'll talk a little bit about solid, but there'll be a whole nother video on solid, right? So for now, just keep it to the focus of this. If you understand this implementation, then you can stop here. So why then do we have more complicated designs? For the most part, I believe it's the what if. the maybe, just in case. Or maybe you're trying to, show off to your colleague that you can design really well. Or maybe you just feel, in the mind you're feeling, oh, so yucky. Listen, that's not the reason to write software, right? If it works, it's good. That's it. It's not about my ego, your ego, somebody else's ego, and how you might feel. This is about the next people that are going to come and implement or maintain the system, or yourself, your future self. You moved on. Let's say you went, 10 years down the line, you moved from C# to whatever else, the fancy languages, and you come back here to your C# code from 10 years ago and think, oh my gosh, what was I thinking? I can't understand this code. No, seriously, I mean, this is, design is not about trying to outdo yourself. Design is keeping it simple. Design is a reductive process. It is not an additive process. In design, you remove. The client comes and gives you a requirement. Your job is to simplify. Your job is to simplify. Not complicate. Not what I would say, don't complicate, simplicate. Right? So this is the simplest implementation. Now, there are a few things wrong with it. But if this works, I'm good. Right off the bat, if this works, I'm good. Now, right away, you are going to write a bunch of tests for this, right? And you will ensure that this implementation is working exactly how you require it to work. So you're going to write tests to cover all bases for this feature. And this is one class in this case, which is fine. The tests are there to help you ensure that this implementation is correct. Right? Your colleagues can look at the test methods, the scenarios, and expectations, and ensure that your implementation is correct, verified to be correct, not just by you, but by others on the team. Okay, so what's the problem with this then? You look at this implementation, you tell me, or not tell me, but think for yourselves, what are the problems with this implementation? I'll highlight what I think are the problems. Right? First of all, it's all happening in one thing, right? Parsing is happening here, persistence is happening here, and the determining of the log source. So this is happening here. Parsing is also happening here, the different parsings, and then the persistence is also happening. So it's all in one kind of class, if you will, one place. Nothing wrong with it. But if you want to keep things a little cleaner, single responsibility, I hear you say. Well, I don't need to talk about that single responsibility thing. Okay. No, I just feel that this is good enough. It's clearly written. There's absolutely nothing difficult to understand about this code. Right now, anything you do to this is going to actually complicate. I'm going to have to start adding things. I'm not going to be removing things. Right? I've brought this implementation down to its simplest form. It's like it's based on first principles. No objects, just methods. Each method has been tested. It's not, of course, directly, but the parsing logic is not a throwaway, right? That parsing logic, if you move it to another class, it's the same logic. So what you're doing, you're testing out that logic. The persistence logic, you're testing out the persistence. It doesn't matter how it's implemented. It's testing out. But here, the method is called parse, but it's doing more than parse. I mean, I can imagine that DetermineLog source is fine, but parse doesn't imply parse and persist, right? So there's a problem here. Maybe you need to change the name, but then the name, what are you going to call it? Parse and persist. So typically the call side will say parse, and then the call side will say persist. There's two forms of implementation I've seen in most people's minds. One is, A calls B and B calls C. So this is what's happening here, right? A calls parse. Parse says I'm going to parse and persist. So from parse it went to persist. So A calls B, calls C. A has no idea that C happened, right? System's working, but A doesn't know that persistence happened. And I don't like that model where you're kind of pushing things forward down line. And it's like all kinds of magic is occurring downstream, and you don't know at the starting point what all is happening by calling B from A, right? I rather say, okay, if I'm A, I'm going to call B, I'm going to call C, I want to call D. I call it orchestration. It's A calls B, A calls C, A calls D. It's not like A calls B, calls C, calls D. You can have it implemented either ways, but this is how I prefer it. I like to see the what is going on, not the how, but the what, and the orchestration. So I definitely want to break these two things out into some separate classes. This I think is fine because somehow they are connected, and we'll have to refactor this a little bit. But for now, my issue with it is the name doesn't suggest parsing, persistence, sorry, and the persistence is also happening here, right? So whatever logic we have here could potentially remain as it is, but it'll probably move into different classes or different methods or whatever. But the idea is the same. This parsing logic is the same since it's been tested. We know it's even working correctly. Okay, so now I'll show you the next implementation. So that was my baseline implementation. I'll just collapse all these. I'll show you the next implementation here. Okay, so this is the intermediate one, as in this is the next step up from baseline. Same method signature. It's called parse. It's got log content, which is a string. It returns a log info base, right? But here, what you can see is it does determine log source, and once it's done that, it just has a case statement for the parsing logic, right? This is a nuance of, or a limitation of C#. I hate this aspect of C#. It's because I'm returning something. So if you look at the previous case, I was not returning anything. So void returning, this case statement doesn't need a default. Maybe I'm not returning anything. Whereas when I'm returning something here, in this case, I'm returning the log info base, then it has a fit in saying not all code paths return a value. It can't tell that there are no other code paths, right? It doesn't know that this method would have thrown an exception if it was the log source was not any one of these log sources. Therefore, in my switch case, I don't actually need more than these 3 log sources, but then I'm forced to put the default here. Do you know what the problem with that is? I mean, am I just scribbling out, C#, like what the heck? Or is there really a problem with that? Do you know what it is? The problem is I can never test that line. There's nothing in my code that will allow me to get there. See, this determined source, if I were to implement this the way I would implement things, the determined log source would throw an exception if the log source is not any one of the supported log sources. This is returning an enum. It's not returning some bool, right? So the only enum it can return are the valid enums. If it's not matching any one of those things, it's going to have to throw an exception. So if that throws an exception here, I can never get to a point here where it executes this. The C# compiler, it complains saying there's all code paths don't return a value. So I'm forced to write that, which is unfortunate, but I can never test it. So anyway, that's there. Okay, so simplified a little bit, similar idea, similar pattern, switch case. All I've done is I'm doing the parsing, I'm not doing the persistence. So imagine now the call side that called this method to say, hey, parse this thing, is then doing the call side, then doing the persist, right? So that's the design I prefer. I'm not going to talk about the persistence part, so you don't need to see that part. We're just focusing on the parsing logic. So this is the second implementation up from the baseline. It's not any more complicated in the sense we remove something from here. See, this is design. You remove, simplify, simplicate. It's a reductive process, not an additive process. Okay, so that's the second version of the implementation. The next version is implementation 2. Okay, now the focus in this implementation was essentially the same method again. There's nothing changed. None of this stuff has actually changed. So there's no change here at all. All these methods here, let's assume they're exactly the same, right? The parsing logic is here. The DetermineLog source is here. All that's changed is the switch case. So all I've done here is really I have used a dictionary. And the dictionary, if you look at the dictionary type, it says the key is a log source. The value is a delegate. The value is a delegate. What is this delegate? It's a method that takes a string as an argument and returns some log info base. Right? So if you look at these parse methods, they're all following that signature. They say they take a string, they return some log info base. Return a string, sorry, take a string, return a log info base, and so on. Take a string, return a log info base. Right? So that's what this delegate is. I call this poor man's polymorphism. That is, when you're doing polymorphism, you're having to define a hierarchy of classes. There's a base class, there's descendants. There's a lot of ceremony behind the whole thing. Suddenly there's a whole bloat of classes that come about because you're trying to get this thing to work polymorphically. And That is expensive, time consuming, etc., etc. You can get the same benefit using delegates for polymorphisms. I call that poor man's polymorphism, because you don't need the ceremony of the classes. You don't have to define inheritance or hierarchies. You don't have to think so hard about what should the base class have, what should the descendants have, all that. It's just simple. There's 3 methods, they have the same signature. Bang, you got polymorphism. But the way you use it makes it polymorphic, not the fact that there's 3 methods. So the way you want to be able to use something polymorphically is saying, I don't know there are 3 implementations. I don't even care to know what these things are. I want to simply be able to call a certain function method on it, and magic should happen, meaning whether it's calling method A, B, or C, I just have to call. I don't need to know whether it's a method A or a method B or a method C. Right? So for polymorphism to be beneficial, it's the call side that has to see the benefit. Right? You can have hierarchies of classes all you want, but if you're not using those classes, the hierarchies correctly, you're not actually getting the benefit of polymorphism. Right? This is the call side. So here, once we've determined the call side, once we determine the log source, call side, the dictionary maintains a collection. I didn't show you the initialization of that. Okay, let me show you that initialization so you understand better probably. So I'm adding different elements here to the dictionary, and this is happening, before the constructor even. The enum and the method, the delegate, which is nothing but the method here. If you don't understand delegates, please take a look at my video here on delegates. That'll make it such that you're sort of really solid on delegates. You understand all the inner insides and outsides of delegates. So if you're even a bit confused about delegates, please take a look at that video. So I've registered with the dictionary, the different enums and their methods that map to those enums, right? So then I use the key to extract the delegate, and then I call it. This may be a little confusing for some of you. So let's just call it. Let's call it here. So what you get being returned from here, from this dictionary, is the parse method. If you were to look at the type here, you'll find that. So in this case, you can see that this is a T and a T result, where T is a string. So the in is a string and the out T result is a log info base. So there's some method that takes a string as an input and returns a log info base as an output, as a return value, right? So that's our method. So this is a method. So now I can call this method. So when I call it, of course, I need to pass it the string, which is the log content. And it returns to me the log info base, so I can return that. And you know what? This is talking about this now. You should be writing code like that, right? That the other code when you're working, this is how it works, right? When you're working alone, and there's a lot of people I know who worked many years practically alone, not in large teams, not building large systems, but very small teams, if that, and working on small systems. They develop certain habits. They have their own ideas and ways of doing things. They're extremely familiar with everything they do. But when you start working in a large team, building larger applications, you start having to consider the team, the other people. Would they understand what you're doing, right? It's not about showing off. It's not about saying, I know this stuff. If you can't understand it, it's your problem. No. If somebody can't understand something in your system, it's your problem. Your problem is not the solution is not for you to teach them. The solution is for you to look at the code and say, okay, what is it exactly about the way I wrote this code that they don't understand? That's how you should be looking at it. So this is the correct way. In my own world, by myself, I can write any code I feel like. But the moment somebody says, what's going on here? Okay, hang on, let me show you. And I'm not going to show you by explaining. I'm going to show you by rewriting the code and say, okay, now do you get it? Okay, cool. Then that's what it should be. That's what the code should be. The idea is to keep it simple. Simple is not easy. You get it? You're going to hear in this series, you're going to hear me say this all the time. Simple is not easy. And it has two meanings. One, of course, that simple and easy are not the same word. Simple is simple, easy and easy. Why? Because simple, complex. The opposite of simple is complex. Easy, difficult or hard. They're not the same thing. Something can be simple and difficult, right? because it's simple, but it's difficult for you. I've done it 1,000 times. You've never done it. But it's a simple thing. The complexity of that is not determined by whether you know how to do it or not. It's simple. By its very nature, it's a simple thing. But because you've never done it before, it's hard. It's not easy. Right? Conversely, something could be extremely complicated, but I've done it 1,000 times. It's easy for me. So it's not the matter of whether it's simple or easy. Simple is not easy. But also, simplifying things. As a designer, as an architect, your job is to simplify or simplicate. I call it simplicate because it's most designers I know, architects I know, they want to simplify. They take the simplest thing possible and oh my gosh, they make it so complicated. If I can explain to you, let's say I want you to build me a shopping cart. I can explain the requirements of a shopping cart in maybe 30 seconds. Minute, let's say a minute, in case you've never heard of what a shopping cart is. So I can explain to you the requirements of my shopping cart in a minute. Why does it take you 50 classes, 20 classes to build me a shopping cart? Keep it simple. That's the point. Keep it simple. Design is not making things complicated. Design is simple, but simple is not easy. It's the hardest thing you will do ever in software engineering. Simplifying things is super hard, and you should be focusing on trying to get things simple. Okay. So that's that. This is simple, and I hope you get this part. Basically, from the dictionary, we extract the we extract the delegate, which is just a method. We call that delegate, passing in the argument, in this case, the log content, and we return whatever that method is. So you see the polymorphic behavior here. The benefit I'm getting here with the delegates is that I don't know the delegate. I don't care to know what comes back out of the dictionary. I want to be able to treat them uniformly. And that's polymorphism. The ability to treat classes uniformly is polymorphism. So I'm getting the benefit of treating methods uniformly. Poor man's polymorphism with delegates. Okay, everything else remains the same. So all I've done really, I've moved the switch case from here to that. And one could argue that what's the benefit? No real benefit. I just wanted to show you that I can use delegates for polymorphism's sake. Now, actually, this would be something I use just because I prefer that this is the orchestration again. See, with the switch case, even though I'm seeing orchestration, it takes a bit to read. Like, what are you doing exactly? Oh, I see. Plus I can't test that. But this is simple. Oh, you first determine, then you call the method, you parse, and you're done. Cool. So that's the steps. Determine what the source is, and then parse it, and return the model that comes out of that parse method. Pretty simple. It's 3 lines. I'm able to understand things. See, humans can't keep many things in their heads. You might think you're really smart, and so you can, maybe you are certainly smarter than me, but that doesn't mean everyone on the planet is as smart as you. So think about the poor me's of the world, who struggle with maybe 3 things in my head, and I'm thinking, okay, I had enough, right? So the idea is that there's only so much people can keep in their brains. Now, when you design the system by yourself, or you came up with the design, it's very easy for you to grok what it is that you did. But then I come along and I haven't a clue. I can't read it. It takes time. When you see me struggling, it's a signal for you to change your design, not for me to learn your design. It's the signal for you to change your design. That's the signal, right? Okay. So that takes care of the third implementation. And now we go on to the final implementation. So let's look at the final implementation, which is up here. All right. Whoa, just look at the, let me zoom this in so you can see. All right. So baseline. Oh, just one class. First implementation, intermediate implementation, 1 class. Second intermediate, 1 class. The final implementation is, whoa, What happened here? Okay, so certainly there are 3 exceptions. So let's ignore the exceptions. You still have 4 classes. So that's 3 extra classes, right? And the question really is there any value to that, right? Is there any value to that? That depends on in what direction is this going to flex? Like, are you going to add more sources? Are the parsers, are you buying the parsers like from like a third party? There are parsers for NCSA parsers. There are parsers for SQL Server. There are parsers for, IS, NCSA, and maybe for Splunk. Maybe not for Splunk, but there are certainly parsers available for SQL Server and IS. Do you want to make your own? Maybe the SQL Server one, even though Microsoft, I think, has both. Let's say you buy the SQL Server one from Microsoft and you buy the NCSA parser from somebody else. They're 2 different parsers. They come from 2 different hierarchies of classes. They probably implement 2 totally different interfaces. Okay, now what? It doesn't really matter. The idea is that there are 2 different classes. Maybe you make your other class now the Splunk version for the exceptions. So the final implementation is accounting for that scenario. But if the system is going to be flexing in that direction, meaning you're going to add more and more sources, then this is the area. In other words, let me just go to a slide. What I'm talking about is this. You've got 3 sources today. You can have other sources tomorrow. And this is an eventuality. It is going to happen. It may not be endless, but it's going to happen. And you know that. Then maybe you want to focus on the way you implement this parsing logic. Now, what's wrong with adding 1 more switch case and an enum? Nothing wrong. Well, if you ask Bob Martin, Uncle Bob, it's all wrong. Can't help but take a dig at Solid. Yeah. Uncle Bob will say, you just got it all wrong. You're violating the open close principle. You're violating the single response tree principle. This design is total crap. And my answer to Uncle Bob is, I don't care. I honestly don't care. I couldn't give a hang whether it's right or wrong. It's simple and it works. To be honest, there's many people who don't understand Uncle Bob. He would say that, but he talks in hyperbole. So I could say the same thing. This is all, stupid design, this baseline, total crap. My final design is total crap. I'm being practical. I'm being pragmatic. It's not about the best design. I don't follow Solid. I don't care. So as a result, I'm going on and on about this Solid thing. But I think the problem is that people espouse to be these Solid programmers, and it's like, that's not the point. Even Uncle Bob, or the person that came up with Solid, he didn't actually invent the actual independent ideas, but he brought about the idea of Solid. At least he didn't publish it as the acronym Solid, but all the acronyms were there, all the letters were there. Michael Feathers then reordered them to Solid. And then since then, it's been known as Solid. Doesn't matter. Bob Martin will tell you that Solid is not the end goal. You're not trying to achieve Solid every step of the way. That's not the point. That's not the point of any design. It has to be practical. As I said, design is about removal, reduction. It's a reduction process, not an additive process. You don't go from 1 class to 15 classes. But in this case, let's assume that this system is going to expand in that direction. More sources will come. And you're saying, well, if that's the case, what all is going to change? What all do I have to change? Right? So of course, in the first implementation, add 1 more switch case. Is that too bad? 1 more switch case and 2 more methods. The 2 methods you would have anyways, right? I mean, there has to be something to parse and there has to be something to persist. Whether it's in 1 class or 10 classes, how does it matter? You still have to write that in that logic. The switch case, but there has to be something somewhere, potentially, that has to account for the additional source. Your enum, well, it has to change. Right now, as I said, as far as Bob Martin is concerned, oh my gosh, you changed the enum. But what's the enum got to do with the parser? Now, two things are changing because you want to add a new source. Oh my gosh, that is not open-close principle. That is not single responsibility. This is utter nonsense. Yeah, you would say that. Oh, and by the way, why the heck is the other classes having to be compiled when you modified the switch case statement, the enum, sorry. The fact that other classes have to be recompiled because you modified the enum is totally bad. It is against the religion of solid. Yes, my dear, if you believe in solid, that's what you're up against. Since I don't believe in the solid thing, I really don't care. All right. Okay. So I'm going to skip the exceptions, and that's really, they're just exceptions. But what I have is a logging, the parser context, log parser context. Anyone familiar with this terminology, the vocabulary, sorry, this context piece? No, this is not context like an ASP.NET or anything. This is the strategy pattern. If you don't know what the strategy pattern is, please take a look at my video here on the strategy pattern. Again, there's a strategy pattern that is presented in the Golf book, which I do not use and I do not recommend. And then they kind of hint at in the book about another pattern, but the one I present mainly or talk about in that video is the second one. Even though I explained the first one that is defined in the book, I tell you what the drawbacks are. They also to some extent highlight some of the drawbacks, but that's not for me the strategy. Strategy is a different pattern. It's similar yet different. So take a look at that. The context in the strategy pattern, the context is let's say the point of entry into your strategy, right? So you have n number of strategies to do something. The context is the doorway. So the call site is looking at the context. It doesn't know about the stuff behind the scenes. And this, in our case, we have this log parser context. It has a method called parse, and it's the same signature, right? All through we've used the same signature. And the parser context is aware of the different strategies. So the parser context will be aware of Microsoft SQL Server log parser and the NCSA parser and the Splunk parser. The call site doesn't know that, and so therefore the context is the doorway. The call site just knows the context, and the call site doesn't know that the context is using one more or 10 classes to do anything. It doesn't want to know that, right? It's just saying, hey, can you just parse this stuff for me? And out comes the model, right? So that's the method signature is the same. Implementation is a little closer to something that, see, one of the values of design patterns, especially if they're implemented correctly, is that they convey a message. Without me having to say much to you, I can just say, use a strategy. And it's all clear, hopefully. Conversely, if let's say I join the team, and okay, the assumption is both of us understand the patterns to be in the same thing, okay, which is in itself a difficult thing in the software field. Each one of us understands these patterns to be totally different. So that alleviates or makes the whole thing much more difficult, right? But let's for a minute assume that your understanding of the strategy pattern and mine are identical. If I joined your team and you said, I'm saying, what the heck are you doing with this? I'm having a hard time understanding. And you say, well, shit, that's just the strategy pattern. Oh, I got it. Like, immediately I know. I don't have to understand the details, but I know because the strategy pattern is simple. Right? I mean, I understand the concepts. So it's not like I have to digest it all right now. So the implementation of this method, however, is still very similar to like our second implementation where we had a switch case statement. There's no persistence going on. It's simply the parsing going on. And the difference is that we now have different classes for the different parsers. With the assumption here that these are not necessarily your class. They could be third-party classes. But the beauty of the strategy pattern is that you don't need them to be in a hierarchy. They could be, but they don't have to be. In the Golf book implementation, they require to be in a hierarchy. In the way I prefer to implement the strategy pattern, they kind of sort of mention it, as I said, but they don't actually go down that detail. But that's the kind of pattern that I have been using for many, many years. That strategy pattern does not depend on or require your implementations of the different strategies to be in a hierarchy, because frequently in the real world, you have parsers for, let's say, SQL Server and NCSA. Why are you going to build your own? Right? They're already there. And now with this whole open source and Nuggets and all that, you can't ensure that they're all going to be coming from the same hierarchy. they'll have the capability, but not necessarily the hierarchy. So, and certainly you can, okay, you tell me, do you know the solution for, let's say I have these 3 different parsers, one from Microsoft, one from some other company, let's say Apache that has NCSA log parser, and let's say you make your own parser, right, for Splunk. And I come there, and I tell you, but this has to be in a hierarchy. My system will only work if all this stuff is in a hierarchy. And you're saying, well, they're coming from different vendors. Yeah, make it work. See if you know the solution to that. I'll, pause, think about it, and I'll tell you now. Essentially, you can still have your hierarchy, and in the implementation of your classes, you can aggregate the other vendor classes. So maybe their methods are not called parse, but when somebody calls your classes parse method, you call the other classes whatever the relevant methods it is, and use those classes to implement. So it's not that difficult to maintain the hierarchy, but I'm not of that. I don't want to do that sort of thing. So the strategy pattern allows you to have a strategy hidden behind a context or encapsulated within a context. And these strategies don't necessarily need to descend from the same base class. They don't have to be a family, even though they may look like they're a family. That they don't have to be. So now I have 3 different classes, or 3 new classes that you saw. In this case, of course, because I just wrote these, they all have the parse method on them, but they didn't have to have. This could be something else and whatever, so I'm just keeping it simple here. And of course, because I'm returning something here, I'm going to have to deal with this nonsense where I now have to define the default, and I can now test this line of code. Now, if you look at the DetermineLog source method, remember that every parser could probably tell you if the content you give it is in its own format, right? So it's not like you should separate that out into something else, right? The parser for SQL Server logs should be able to validate if that log is a SQL Server log, and the parser for NCSA logs should be able to validate or let you know if that log format is the correct format for it, and so on and so forth. So all that I'm doing here is I have moved, in this implementation, I'm using the different classes for their to help determine if any of this log file is any one of their own formats. Right? And then I return the right one. So in the previous implementation, it was muddled in the sense that the parsing was somewhere else and the determining was left to something else. The parser should be able to tell you if the log formats are correct or not. And so they're in the class. If I were to show you one of these classes, you'll see that there's 2 methods. There's a public method that says is log valid format. Is log format valid. And when you do the parse, it also ensures, because the ensure is doing the same thing, is calling the same method, right? But the parse method first ensures that the format is correct. And if it is, it'll, of course, these are all throwing exceptions here, but if the format is correct, it'll go ahead and do the parse and it'll return an instance of that. So every one of the parsers should have some way for you to help determine whether the content, in this case, is the right format. Right, so all the implementations kind of look like that. So that's irrelevant, really. Not that important. The important part is that this is now the context, the log parser context is your strategy. It has a method, public method called parse. It returns a log info base. The call side, of course, will call the context, get the parsed, come back with the model, and call the persistence method to persist the model. All right, makes sense. And something else I want to show you or focus your attention on, essentially, is just the naming convention of these classes. So I'm speaking specifically about these 3 classes. So note the name. It says log parse strategy MS SQL, log parse strategy NCSA, log parse strategy Splunk. And the reason is that all of these will be together in the Solution Explorer, and you won't have any issues with trying to find or even know that they exist or not, right? So I've been following this naming convention for many, many years now, where I find that this is a lot easier for me to understand a system and for others to understand what I'm doing or I have done over the years, where class names, the names are kind of flipped around. So calling a MS SQL log parser I call it log parser in this case because they are strategies. They're named like that. Log parser strategy, SQL Server, or MS SQL, log parser strategy, Splunk, log parser strategy, NCSA. It's a lot easier. And I will use context to mean, it's the context of a strategy in the strategy from the strategy pattern. And then I'll call classes strategy. So it's very clear. Gets a bit wordy. It doesn't have to be done. But over the years, I've found that as I'm working with different people over the years, it's just once you name something, oh, that's a strategy. Immediately their mind is focused on that. By just looking at the implementation, they can certainly decide that. But by looking at the class name now, oh, that's strategy. Okay, cool, I got it. So there must be others in the strategy. Right? All right, so that's that. And so, yeah, I'm done with the different implementations. I'm just going to show you another slide here. The baseline implementation. The reason to implement the baseline is, first of all, it gives you a sense like a platform to stand on. Say, okay, that's your base and this thing is working. Now, what's the problem with this? What benefits am I going to get? Is it too slow? Is it going to become faster if I have another implementation? All of those things. If such a need arises. Listen, if you're building a system that has no real need for super duper performance, you really don't have to do anything for it. Right? If the baseline works, that's fine. Now, if you didn't know that part of the system that you're working on, this baseline that we just built, is going to expand. Let's say it wasn't ever going to expand. We're always only going to be looking at SQL Server. We're always only going to be looking at Splunk and IS logs or NCSA logs. That's it. We are not ever going to have another source. The first baseline is just fine. Keep it simple. Keep it simple, stupid. You heard the kiss. Keep it simple, stupid. Yeah, keep it simple, stupid. Well, maybe I should just call it KIS. Keep it simple. Yes, keep it simple. The need to go overboard and say, oh, well, I need to be able to do this and that and use all these interfaces and make all these classes and use, the solid principles. The problem is people don't understand when. Solid is not to be applied at the get-go. That's not the point of solid. Unfortunately, Bob Martin didn't make that clear. He does later on in some obscure places actually mention that when people are, asking him these questions about, code bloat and over-architecting and this and that. Then he kind of comes out and says, you're not supposed to be using solid like at the get-go. It's only when you need it. But that's all design. Keeping it simple is all about not putting in stuff you don't need, that you may never need. You don't know yet. You're building for now. You're designing for now. You're designing for what you know, not what may happen. It's not the what ifs, the just in cases. Don't know. Now, what do you know now? So if you don't know now that you are going to require other sources in this case, then don't bother. Idea is you recognize the shortcomings of your, let's say, baseline. You have to recognize that. The number one telltale sign of a good designer is you recognize the flaws. Not that you fix the problem. I show you the baseline. I say, hey, that's it. It works just fine. I got all the tests. It's working fine. If you say, oh, cool, it's working, right? Oh, well, that's cool. Or you could say, well, that's all single responsibility, blah, 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 blah. Let's just pick it up. That's not recognition of the problem. Do you understand the flaws in the design in the first implementation? If you do, understand the flaws and take stock and say, well, does that really matter to me? It maybe doesn't matter to you. To you by you in that system, in that context, in that company at that moment in time, right? It's okay. So what? How does it matter? So it's all combined and, jumbled up into one class. Who cares? Where is the value to going to the second, third, and fourth implementation for the same thing? Leave it at the baseline. So then the crux of these design nuggets is not only to show you about the process, but show you the different cool things you could be doing from a design standpoint. I also am trying to stress that design is about simplification. Simplify, reduce, remove. Don't add. That is not design. That is blooming solid. Remove, take away, right? Keep it simple. Only do it when you need to know what to do if a certain situation occurs, but you don't have to do it now, right? The mark of a good designer is not saying, oh, well, I know I can improve on it, so therefore I'm going to improve it. No, the mark of a good designer is recognizing the problem and doing nothing about it until required. That's when you're a good designer. Till then, you're just following along. You're not designing. You're following along like the rest of the world. Solid, all this stuff. Okay, so I'm going to go through the different parts of the slide here. So the baseline implementation, always start with the baseline implementation. And there's a reason for that. If you look at the graph over here, that's your baseline. Now, once you implemented the baseline, you look at, yeah, I could do this. I could improve it this way. I could improve it that way. So now you got 3 different variations to that one baseline. The baseline works. But that exercise of implementing the baseline has opened your eyes to, oh yeah, I didn't think about that. I had this problem here, but now I have to solve it like that. Okay, cool. So once I see that implementation, I get other ideas. And those are these variations 1, 2, and 3. So now you've kind of branched out into 3 different variations from that original implementation. It is important to actually do the implementation. Don't do a mental exercise. Do the implementation. You'll be surprised at how many weird things you come up with that you never thought about in your head, even though you got 20 years of experience. But now that you're expanding your horizons, why would you not want to implement the baseline and then take it from there? Look at the possibilities. If you jump from problem to solution in one step, what have you lost? Do you recognize all the other things you could have been doing that you missed? And are you going to go through your life just jumping from here to here and without looking anywhere else? It's like being on the highway versus the scenic route, right? Yeah, being on the highway has a meaning, has a value sometimes. When are you going to learn? When are you going to expand your horizons? Look at other things you could be doing. Every time I do the same thing, I'm still starting from the baseline, hoping that one day I'm going to choose this direction instead of that direction. I'm going to end up here. I'm going to learn 10 other things that I never ever experienced before. Maybe for that specific system or company or whatever team, this direction actually is more beneficial than that direction that I've been going in all along, all my life. Right? So it's important to go and branch out. Then once you get to variation 1, you have other variations stemming from here and so on. Right? So I'm not going to list out all the different numbers here, but the idea is from the baseline, you have variations. From each of those variations, you have variations and so on and so forth. It's a huge number of possibilities that you're losing by jumping from problem. But here's your solution. Now, even though you have many years of experience, as I say, go to the baseline. I am guilty of doing the same thing, right? There are many times, I've already done this before, so here's the solution. But really, for the most part, if somebody says, what do you think, Shiv? And I'm thinking, well, I might go down this route, but I don't even want to be, it's like you're asking me to commit to something. I don't want to. I want to play with it. I want to experiment. I want to build that baseline. And we could do it together. It's not like I have to do it myself. And I want to kind of go on that way, right? Every time I do the same thing, I'll still start from the baseline. And there are many, many times I'll take this variation over that variation for the sake of maybe the team. Maybe there's somebody on the team that says, hey, I like this thing better. And I say, like, why do you like this better? Oh, well, because blah, blah, blah. I didn't think of that. You should feel comfortable saying, I didn't think of that. I've never done this before. You have to have that humility to say, I never, 20 years of my career, I never did that before. Never thought of it. Yeah, so what? Now you know. And now you know more. So the baseline is important because you can read all the other bullets here. You write the tests, you ensure that the tests are verifying your functionality. And that leaves you, of course, when you have different implementations, the same test can be used to ensure that the newer implementations are also conforming to the requirements and nothing is broken or nothing is not working. Right? So that's the one important aspect of that. Design, simplicity, simplification. Simple is not easy. Simple is not easy. Okay. Design is a reduction process, not an additive process. Complexity undermines your ability to understand, to comprehend. More complex things are, the less you're able to understand. It is a massive speed breaker in your journey to understanding things. Not just maybe see for you, something that is complex is not difficult for you. It's simple for you because you wrote the damn thing. But poor me, I come along and I'm struggling trying to figure out like what the heck is going on. I mean, like this is just way too much stuff for me to juggle in my head. That is too many things. Keep it simple. To be a good designer, you have to be able to simplify. You have to be able to simplify. Okay. And then, right. And the refactorings that we went through, like from the baseline, the refactoring steps that we went through, the aim was slightly, we know it's working. Right? So we have what it takes. It's working. We have a functional version of it. We're good. We can go to production with this one right now. Right? The tests are telling us everything works about this thing. There's nothing absolutely wrong with it. But then you refactor, you try and improve on things. But what are you doing that for? So what you're doing that for, as you can see here, is to clean up your code, improve readability and maintainability. This is huge. For me, maintainability trumps everything I do in my design. If it's not maintainable, I don't care for it. If it's too complicated, I don't care for it. It may be a better design. I don't care. I'm not chasing a good design. There's no award in software for the best designer of software, this year. There isn't any. So you're not going to get it. Keep it simple. Unfortunately, there's no award for simple designs either, but there should be. Okay, so your driver is maintainability, readability. Not best design. Simple. And you're not designing for the what ifs and the just in cases and the maybes and I don't knows. Design for what you know now. Design for what you know now. Just this instant. That is important. If your design is good and things are simple, you can easily, believe you me, easily extend your system. I've never had trouble extending my systems. But they're simple. The more complicated it gets, the harder it becomes to change direction. Simple systems, built simply, designed simply, can change in a different direction or expand in a different direction, things you're not built in for. Because remember, the decisions you're making to keep things simple, you're still aware of the flaws. It's not like you don't know. That baseline, I know exactly what's wrong with it. But it doesn't matter. It doesn't have any meaning or purpose or value to the system at this point in time. So then I don't need to go to the next version or the next version or the next version. I can leave it there. But I'm aware of the flaws. You have to know the problems. But you can choose to ignore them. That is design. All right. Well, I'm sorry about the rant. The design is a near and dear topic and I'm trying to teach it. I'm not sure it's something that can be taught. It's something that you have to experience and you learn kind of over experiences. But let me know if you learned anything. I hope you have learned a few things. I hope you've enjoyed yourselves. If you have, please give me a thumbs up. And I will see you next time.